So again, make sure you watch these videos of the titration that I've put into Edpuzzle because it's a very important method that we use as chemists. So here's our equation for titration calculations. MAVA equals MBVB, and it looks really familiar because it's what we used when we did dilutions. M, of course, is the molarity, V is volume, and the A represents this is the molarity of the acid, and the volume of the acid is going to equal to the molarity of the base times the volume of the base. So it's very much like the calculations that we did before. The other thing you're going to do in these questions is you're also going to write the chemical equation for this. So in this example, it says we have 15 milliliters of 0.0250 molar HNO3 required to neutralize 10 milliliters of KOH. What is the molarity and pH of the KOH? So we're going to write the balanced equation, the neutralization equation. So we've got nitric acid reacting with potassium hydroxide. Just like I talked about before, the H and the OH are going to make water. And then the other two ions combine. We've got potassium as the positive ion and nitrate is the negative polyatomic ion. So we end up with KNO3. And again, it doesn't need any further balancing. It's just balanced the way it is, which is very nice. And then we're going to make our list of variables over here. 15 milliliters of 0.025 molar solution of HNO3. Since this starts with H, we know that's our acid. So the 15 milliliters will be the volume of the acid. And the 0.025 will be the molarity of the acid. And then it neutralizes 10 milliliters of KOH. OH tells us that this is our base. So the volume of the base is going to be 10 milliliters. And of course, we're being asked to find the molarity of that. So we're going to take our equation here and rearrange it. So we're going to end up with MAVA over VB is equal to MB. We plug all our numbers in there. 0.0250 times 15 milliliters. Divide by the 10 milliliters. And we end up with 0.0375 molar. I'm running out of space on my page. So this is the molarity that they asked us to find. Now, some of these questions also ask you to find the pH of the solution, and so you have to do a little bit extra calculation. Now, because we found the molarity of the base, if I take the negative log of this number, I'm actually finding the pOH because it's got an OH in the formula. So the pOH is going to be the negative log of 0.0375, which is 1.43. Then if we wanted to find the pH, we have to remember that pH plus pOH always equals 14. So if we do 14 minus 1.43, we end up with 12.6-ish. I've just kind of rounded everything off to 3 significant figures because, again, pH and pOH have a weird number of significant figures. So some of these problems are going to ask you to do this extra step, and some of them just stop and ask you to do the molarity. Make sure you write the balanced equation first, and then show all your work for the calculations. Please email me with any questions.